So when we look for new star formation in our galaxy, we're going to be looking for those nebula regions, or those molecular clouds that we talked about earlier when we talked about how stars are born. And actually, in around massive stars that live their lives quickly, we do see these ionization nebula that can be used for new stars to be born coming up in the future. Okay, so this actually is a pretty type of nebula called a reflection nebula, and what's happening is light from those stars is being reflected on nebulous material that is potential fodder for new stars to be born. If you're familiar with the Seven Sisters or the Pleiades, actually they also have a reflection nebula. They have a bit of nebulosity in with those stars that are already stars. So this is pretty. This is also in Orion. Orion is a busy place. This is the Horsehead Nebula. And actually the Horsehead Nebula is a type of nebula. I told you, remember that the Milky Way in the nighttime sky, we kind of see, it has some dark patches. And so for that, I call that dark nebula. And actually here we're seeing a dark nebula kind of intersect or overlay on top of a brighter emission nebula. So that's kind of cool there. Very cool. But when we look for star formation, we need to look for these nebula or molecular clouds. And so what we see is that the disk area of galaxies such as ours still has these nebula material where stars are being born. And so in our disk we have an assortment of stars that are different ages. And in the halo region, we generally don't see fresh snow to make fresh snowballs. We generally don't see dust up there in nebula in order for new stars to be born. And the stars up there tend to be generally old. So this is actually a photograph of a spiral galaxy, kind of what we call face on. And you can see the beautiful spiral arms, and actually those would be the happening place for stars to be born. This is called the Whirlpool Galaxy. So, but spiral arms in spiral galaxies are a little bit deceiving in that they don't like arms, I should say like the hour and the minute hand and a clock. You know, that material kind of stays together and it sweeps around. But that's not what happens with the stars in the spiral arms of a galaxy. Material kind of moves in and out of these regions, and as it moves into these kind of regions of compression, these stars can be born, and then it's just not a rigidly happening sort of thing. The arms don't stay intact. So it's kind of a neat, I've seen it described, it's kind of a neat phenomenon. So this, isn't this pretty? So this looks more now like a photograph of looking at the galaxy as we know it. That this would be the Milky Way, and kind of showing you stars in the halo region above and below the disk. And in the disk, I mentioned that we find stars of all ages. And so depending upon how much the stars generally have what we say heavier elements, like our star has iron in it, that sort of thing. We know that that star, because it has heavy elements like iron, it was made from another star who lived its life and gave its matter back, and then we were made. Does that make sense? So we generally say that the stars in the disk generally are metal rich. Right. And if we compare, because they're metal rich or related to that, we have a term called population 1. And I will warn you, it feels a little backwards to me. But population 1 stars would be those stars that, like ours, like the sun, that was made from previous stars. So population 1 is kind of generations down the road. They would be like grandkids or great-great-grandkids, that sort of thing. Okay, so, and if we compare the how much of the stars in the halo region is with regard to their heavy metals, we see that they are generally what we call metal poor. Okay, they don't have the heavy metals or elements that the disk stars have. And in general, we say that they are kind of like a little more primordial, or they are the earliest generations of stars for our galaxy. We call those, don't blame me, but we call them population 2 stars. It seems a little backwards. So population 2 would be like the great grandparents or the grandparents or the parents, okay? Does that make sense? Well. And so I'm going to introduce a term. I don't think I've used it yet, but we've been calling the region above and below the disk, we've been calling that the halo region, and it is. But another term for that would be the spheroid or spheroidal region. So our spheroidal region, or the population in the spheroidal region, or halo stars, tend to be kind of older stars, population 2. And then in the disk, we have an assortment of stars, different ages, but we definitely have our newer stars or population 1 stars being formed out of stars that have lived their lives and given back. Kind of, we've talked about this recycling, galactic recycling.